just want to remind you, okay, not only the project 3, but also the final, project has have been like posted to the E class. Okay, please, check it out, and I think by now you guys should have the members that you will be collaborating with, like for the final project. Okay, if not, I'm sure TA is going to arrange, like if you cannot find like another group to work with the final project, TA is going to do the matching for you. Okay, but so it's about time. Okay, because I just checked the calendar. We only have like 4, I think, including today's lecture. Is that right? Including today's lecture, we have. Let me double check. Today is 9th, right? Okay, December 9th. Okay, so where is this? Oh, here. Cannot find. Huh? My mouse pad is not working. It's something's wrong. Huh? Wait. Yeah. Yeah. The computer is some issue. Okay. Oh. My computer freeze on me. So, yeah. But 没有办法反应呢，奇怪。你有看到我的 mouse 吗？不见了。
在这边。啊？就是延伸了。
延伸了。
就是把它移回来。这样。对，这样。这边好拉回来。
哦 ，OK。
只是这个视窗感觉要拉过去。
这拉，怎么拉过去？
应该把它缩小，然后往右拉。
没有啊。
右边，对。
Okay. Okay, if you check the calendar, today is the 9th. Oops, 那我现在看不见。
还是老师我们把
没关系，
换成两边屏幕同时。
对啊，奇怪，以前不是都是这样子吗？为什么会发生这个事情？
我帮你设定一下，好吧？
显示是不是这个啊？
应该不是，应该是有一个在。系统中，选显示器。这个。然后显示器设定。然后，这个把它镜像输出。
这样子吗？
这样子是两边同步的。
好吧 ，OK。
那个不会，它就不会延伸。
好，谢谢。 奇怪，以前好像都没有这个问题。Yeah. Anyway, so. But if you check the calendar, okay, today is the 9th, okay, and so including today's lecture, we have 1, 16th, 2, 23rd, 3, 30th, 4, and then, okay, in January, we have another 2 classes. Okay, actually the 13th, okay, January 13th is going to be the final exam if my memory serves correctly. Okay, that's the final week. Okay, final exam week. Okay, but so I don't have class beyond that. But you know, for this class, okay. The final week is going to be used for the project presentation, okay? So we are going to do like the term project presentation on the 13th, okay? So, which means the final exam is going to be a week before your final project presentation, which is like the final exam is going to be on the 6th, okay, on the 6th of January, okay? So that, you know, that said, okay, we only have like 4 lectures left, including today's lecture. Okay, so I don't know why, but it's slower than what I usually is able to cover for this class. But anyway. Okay, it looks like we will be able to finish the RNN, and I'm going to talk about the representation. Okay, which is an auto encoder, and hopefully I'm able to finish that chapter, and that's pretty much about it for this semester. Okay. Last time I covered this class, I mean, I was able to talk a little bit into the reinforcement learning, but unfortunately not this semester. But anyway, okay. So last time we talked about the basic idea about the recurrent neural network, okay, and I'm sorry. Yeah. So there are 4 commonly seen recurrent neural network architectures. Okay, something like you know, what we show in this slide. Okay, the upper left one, the upper right one, lower left one, lower right one. Okay, so the upper left one is called sequential, sequence to sequence. Okay, sequence to sequence. Okay, you have the input is a sequence, the output is also a sequence. Okay, and the upper right is sequence to vector. Okay, the input is a sequence, the output is a vector. Okay, and the lower left is a vector to sequence. Okay, in which the input is a vector and output will be a sequence. Okay, and the lower right one is the most, perhaps the most important one. Okay, in the RNN. Okay, if you go to like see some papers in RNN, most of the papers, I mean, use this encoder decoder architecture, and the encoder, if you look at this one closely, this is just like a sequence to vector, right? The encoder is basically a sequence to vector, okay? And the output vector will be sent to the decoder, which is like just like a vector to sequence. Okay, so we have this 4 different commonly C architecture. I'm not saying like RNN, okay, only has these 4 types. I'm not saying that, but I'm saying like these 4 types are the most commonly seen like RNNs. Okay, so the first one, okay, it takes a sequence input, produce a sequence output. Okay, so in what applications do we use this? Okay, for example, okay, if you receive like a number of inputs, okay, from the past, and you want to predict the next the future trend. Okay, for example, like you get the stock price of the previous n days. So that's your input. So that is why, okay, the input is a sequence, because that's the stock price of the previous n days. And it will output the prices shifted by 1 day into the future. So from n minus 1 day to ago to tomorrow. Okay, so in some sense it's like let's say, okay, this one is like 1, 2, 3, 4, 5. So this is yesterday, the day before yesterday, the day maybe I will use date. What's the date today? It's a 9th, right? So today is 9th. Okay, let's say we already know the stock price today. Okay, stock price, the stock market ends at what time? What time does the stock market like close every day? 3 p.m. I guess you guys don't know. I don't know either, because I don't invest on stock price. Okay, when I was in college, okay, there was like Taiwan has like the first Taiwan stock price like reached like 10,000 point. Okay, for the first time in history. So I borrowed like 100,000 from my mom and invested on the stock, and after 3 days, okay, before I can earn my money, okay, back, so the stock collapsed, and at the end, after like about 2 years, I finally sold my stock at like, because the stock I bought was like $98, so it cost me like 98,000. Okay, and at the time when I sold the stock, it was like I can only get like less than 30,000 back. So that's like a terrible experience, right? Okay, because it's like almost everyone at least like at some point of time earn some money. Okay, but I was the only, at least I mean among all my friends, okay, I was the only one who lost the money. Okay, I mean I only invest once and lost like 60% of my investment. Okay, that's crazy, So after that event, okay, I stopped like doing any investment on the stock. So I mean I don't know like what the stock market situation is like nowadays, but I know like a lot of people still making money on stock. Okay, so anyway, let's assume, okay, today is nice. Let's assume the stock market has closed. Okay, so we know the point today. Okay, so this is the today's situation. So 9th, 8th, 7th, 6th, okay, and the 5th. Okay, the points for these few days, okay, will be input, okay, as a x4, x3, x2, x1, x0 into this one, into this model, and this model is going to output, okay, the 6th, the 7th, 8th, 9th, and the 10th So you can see from Y0 to Y3, they actually they still represent the past information, right? Only Y4 represent the future information. Okay, that's normally what we do. Okay, when we use this model to do the prediction for time series data. Okay, so this is like I'm sorry. This is what we meant by here. Okay, so even though I stop investing money on stock price, but my lab did have like a research on the stock prediction. Okay, so of course the model may be slightly different from this one, but you get an idea. Okay, so the second type. Okay, so you can fit a sequence of input and ignore all output except for the last one. Okay, so this is like something like this. Okay, of course you could also use this one for prediction. Okay, but it's not as good as the previous one. Okay, why do I say that? Okay, I will explain later. You may feel like I mean, well, these two models. I mean, doesn't this second model exactly like the first one? I mean, when we ignore the other output, just focus on the last output. Conceptually yes, but it's going to be different when you start training the model. Okay, so I will get to that point later. Okay, but other than the predicting like time series data such as stock price for the second model, okay, there are other applications. Okay, sorry. Okay, for example, you could fit the network sequence of words corresponding to a movie review, and the network will output a sentimental score. Okay, maybe it's going to be from -1 to +1. Okay, -1 means the review is a negative review. Okay, the reviewer hate this movie, and +1 means the reviewer love this movie. Okay, so basically, I mean, based on the input, okay, which is a sequence of words, right? So, I mean, this model can try to translate that into a score. Okay, so this is like the common application for the second model. Okay, the third one is like it's opposite. I mean, we feed it a vector input, and it's going to output a sequence, right? So the application like for this type of model is like okay, you can input an image to this model and expect that model to output a caption for that image. Okay. So the last one, okay, the encoder decoder model. Okay. Well, this one is famously to be used as a for the translation task. Okay. When I say translation, I mean like input is maybe is a sentence from one language. The output is a sentence for in another language. Okay, for example, the input may be a sentence in French, and the output will be a sentence in English, the corresponding sentence in English. Okay, so in this particular situation, okay, when you are using this for translation, every word count, including the last one. because you don't know if the last word, okay, is going to change the meaning of the whole sentence, right? So you know, this is like a, you know, sorry. So this is going like a, what happens like you are going to feed like each word into this input, okay, and after every word, okay, is in the input is collected, okay, it's going to be translated, it's going to be embedded into a vector, which will then be decoded, okay, into a sentence of different language. And as you can see, okay, after the discussion of these 4 types of model, okay, the first type of model, as I said, I mean, it's mostly used for the time series prediction, right? But the second one, third one, the fourth one, if you look at the application of this model, these types, okay, closely, okay, they are all about natural language processing. Okay, the first one is about what's that? I mean, the input is movie review. Output is a sentiment score, right? This one, the input is image. The output is a caption. This one is a language translation. So no matter which one we are talking about, okay, you know, the language, okay, I mean, natural language processing type of task will be, I mean, is involved, right? So that's very nature because, as I said, okay, the NLP make use. NLP is a big field in deep learning now, okay, and it makes use of the RNN a lot, okay. So, but I'm going to stop, you know, there, okay. If you want to learn more about how to apply RNN in NLP, you know, our department has other professors to talk about that. Okay. So now, I mean, we need to discuss like how the RNN is trained. Okay. So this has something to do with like you know, why do we prefer using this one instead of the second type for time series prediction, okay? So first, okay, the training, okay, we know like for the feed-forward type of neural network, even including the, you know, huge convolutional neural network, okay, basically we are using what we call backpropagation, right? Backpropagation. But in RNN, it's slightly more complicated because we know the network in the RNN is going to unroll through time, right? We talk about that, right? Okay, as like the network, okay, progress through like timestamp, okay. The model actually like not only the output of the model is based on not only the current input but also all the previous inputs. The reason is because like the unroll through time nature in RNN, okay, it is not a feed-forward type of neural network. Okay, so the backpropagation, okay, in this case, okay, has a different version. Okay, we call it backpropagation through time. Okay, BPTT. Okay, so this is how the RNN is trained. Okay, so let me use an example to show you. Okay, so if your output sequence, okay, is evaluated using a cost function like this. Okay, let me show you the figure. If this is the output cost function, if this is cost function, which is based on a certain output, okay, in your RNN model. Okay, you have a Y2, Y3, and Y4, right? So those will be taken into account in your cost function. And then, okay, what happens is that, okay, we are going to calculate the gradient, okay, here. And then, okay, you can see like the gray arrow, the gray arrow represent how the forward pass is done. Okay, and the solid, okay, dark arrow shows how the gradient are sent back to your model to adjust the weights. So this is very special. Think about this. Okay, so for example, okay, this W basically and the B. Okay, W is a weight, B is a bias. Okay, all this W and B represent the same set of W and B. Okay, they are the same thing, but you can see this WB will be affected here. Okay, but this WB will also, okay, the same set of W and B will be affected by this gradient and this gradient. So the same set of W and B, okay, is going to be affected in multiple ways. Okay, it's in a regular feed-forward neural network, the forward pass goes like this, and backward pass goes like that, right? So it's going. So the weight and the bias, okay, that I'm talking about for a neuron is going to be affected only one time. But this one, okay, obviously the same set of WB is going to be affected multiple times during the backpropagation in time. Backpropagation through time. Okay, so this is very different. Okay, that is the reason. Okay, think about this. Okay, the cost function. Okay, it depends on what output will be considered in the cost function, right? So let's go back to this one. Let's assume we use both model to evaluate the time sequence. Let's say stock price. Okay. So in this case, okay, you can imagine only this because this Y3, okay, only this Y3 will be useful to compare with the ground truth, right? And you have a gradient to throw back, right? So the gradient, of course, the gradient will come back to affect like the whole network. That's correct. But in the case like this, you are going to use the whole set of this output to compare with the ground truth. Okay, and then because of that, the gradient that's going to be thrown back, it's not going to be just Y4 here. Okay, you are going to have a gradient flow back at Y3, at Y2, at Y1, at Y0 as well. Okay, so when it comes to time series prediction, okay, because you are going to get more help. Okay, more help from the gradient flow back. Okay, in the back propagation through time. Okay, in the first type of model, compared to with the second type. So that is why, okay, we normally prefer using this one to do the time series prediction. Okay. I hope this one explained. Well enough why this one is better for time series prediction than the second one. Okay. So Now let's consider, a concrete like example of that forecast a time series. Okay, so suppose we are studying a number of active users per hour on the website, or the daily temperature in the city, okay, in Zhongli, okay, or the company, assume you have a company, okay, our company's financial health measured quarterly using multiple metrics. Okay, so in all three applications, all three cases, okay, the data will be sequence of one or more values per time step. Okay, they are all what we call time series. Okay, time series. Okay, and so for the first two examples, for the first two cases, okay, we need to see the number of active users per hour on a website, or the daily temperature in the city. Okay, I mean, when I say daily temperature, of course, I mean like maybe average temperature. Okay, because I only output one number, right? So the first one and the second one both will output one number. Okay, so like number of active users per hour, that's a number. Like daily temperature, okay, of course I assume this is an average temperature. That's also one number per day. Okay, so these two examples are what we call univariate time series, because at each time step you only have one number. Okay, but the third one, you want to measure the company financial health. The company financial health is normally measured by multiple metrics, and each metric may have a number. Okay, for example, okay, you can measure the company's health by the company revenue, the company debts, okay, and maybe company stock price, okay, something like that. So each one has obviously a number at a timestamp, right? So so this is also a time series data, but we call that multivariate time series. Okay? So a typical task is to predict future values. Okay? So when we predict future value, another way to call such a task is forecasting. Okay? So we want to forecast the time series data. Okay? So another common task is to fill in. So this one is different from the previous one. Okay? So the common task is to fill in the blanks. Okay, sometimes, when you collect the data, you may have some missing entries when you collect the data. So you need to, fill in this, try to find the best value, okay, to fill in those missing data. So we call that type of task imputation. It's not forecast, because forecast is look into the future, right? So this one is like we are look into the past. But when we look into the past, no matter it's imputation or forecast, they have similar nature in the sense that we don't know the real value. We don't know the real value. Of course, when we train it, when we use when we train the model, okay, we may have like a ground truth, but when we really use the model to do either forecast or to do the imputation, we don't know how well that fill-in value is going to be, unless we can obtain. Of course, if it's a forecast, when the time comes, we know the result, right? But if it's past, missing value, maybe somebody else recall that value, then we can compare that, our predicted value with that with somebody else's data set, okay, and see like how good that imputation is going to be, okay. But anyway, so these two tasks, okay, have different nature, okay. So for example, okay, the figure in the next slide shows 3 univariate time series. Each of them has 50 time steps, okay, and the goal here is to forecast the value at the next time step, okay, which will be represented by a cross, okay, for each of them. So let me show you. It's something like this. You can obviously see like this is a time series data, okay. Even though we don't know what this is, okay, it doesn't look like you could explain it as a stock price, like a trend, okay, or you could explain it as something else. I mean, well, we don't know, but anyway, we have like from time step 0 to time step 49, but we don't know the value at the time step 50, so we put a cross there. Same thing goes for the second and third figure. Okay, and for all these 3 figures, okay, these 3 examples are about the forecasting, okay, it's not about imputation, okay. To be honest with you, okay, for imputation task, okay, normally we don't use RNN. We use RN for forecasting, but we seldom use RN for imputation, okay. So you may ask, how do we solve the imputation task? Okay, the imputation task can be resolved, okay, normally by autoencoder. Okay, autoencoder. Hopefully, we are going to talk about that. I mean, in this semester, okay, before the end of the semester, okay. So, so now, okay, what we need to do is, because we are trying to make up an example, right? We are trying to make up an example. So first thing first, we need to generate certain time series data, okay? So we need to write a program that generates the time series data. Of course, supposedly this data should contain certain, what should I say, like time series nature, okay? Maybe I should say that. I mean, basically it's like it's randomly up and down, right? Okay, so what happens is like you can see, okay, we define this function, okay, we call this function generate time series, okay, we have a batch size, n step, okay, so frequency 1, frequency 2, offset 1, offset 2, and these 4 numbers are randomly generated. Actually, we randomly generate, I mean, 4 numbers for, for the number of batch size. Okay, so if the batch size is 10, we generate like 4 times 10. Okay, this many, random numbers. So time equal to, okay, it's a linear space. Okay, so maybe the easy ways. Okay, you can see here. Okay, it's a sign. It's a sign. The NumPy sign. Okay, we call that the sign function. Okay, because obviously, I mean, time series normally has certain. It doesn't have to be exactly, but normally has certain, up and down, right? So when you see imagine up and down, or like a kind of like a, like a period, okay, this type of nature, okay, the sine cosine functions, I mean, will be easy choice for you, right? But here you can see that, okay, we actually, okay, use those random value, okay, to as the input of a sine value and also the offset, okay, as an and also we as an amplitude of the sine value, and then we intentionally add 2 sine value, okay, just to make it like a more difficult to predict, okay? Make it more difficult to predict. And then after that, we also add certain noise, okay, into the result of the summation of the two sign value, okay? So that's about it. So this function will create as many time series as requested, okay? So as for how many, okay, I mean, it's up to the batch size, okay? We can create, for example, if we want to create three, then we just have set the batch size to be 3. Each of length n step. So if we want the 3 time series, each one with 50, then the n step will be set to be 50. Okay? And there is just one value per time step in each series. I mean, just like this. If you want like each step, okay, in the time series to contain multiple dimension, okay, if it's like one value per time step in each series, then that's the univariate case, right? So if we want to return maybe 3 values for each step, okay, in each time series, then what we need to change is here. Okay, this one, I mean, we need to change it to something else. Okay. So then we can, once we have this function, okay, we are able to, use this one to generate the certain number of time series data for us, okay, and we can use it for as an example to train our model, right? So so we can create a training set, validation set, and test set using that function. So n step is 50. We have like a 50. We generate like a 50 data point, okay, for each time series, and series equal to generate time series. Well, we have 10,000 different time series. Each one we have like a 51 steps. Okay, because n step plus 1. Okay, why do we put the plus 1 there? That's because we want that, what should I say? We want to look into one day in the future, right? So that one additional 1, okay, represent the ground truth, basically. So we try to break this series into 3 different sets. The first one is a training set. The second one is a validation set. The third one is a test set. Training set has the first 7,000 series. I mean, out of those 10,000 series, okay. And the validation set has the next 2,000. Okay, the rest of 1,000 belong to the test set. Okay. So I think like this is very easy to explain. Okay. So so now we have the data prepared. Okay. In the next class, okay, let's take 10 minutes break. In the next class, we are going to see how we can predict using different model. Okay.